Hi students, in this video I am going to give you the important concepts of amines chapter. So amines is the smallest chapter of organic chemistry where you will score 7 marks for this academic year. Okay, so in that 7 marks you will get one 2-mark question and one 5-mark question, and there is no direct 5-mark question. You will get 2 plus 2 plus 1. Okay, in this manner there is a chance to ask 5-mark question. That means 2 2-mark questions and 1 1-mark question. Totally 2 plus 5, it is of 7 marks. We'll see important questions for both 2 marks and 5 marks. So in complete chapter of amines, you want to concentrate on the most important concepts, that is Huffman bromamide reaction, Gabriel phthalimide reaction, carbylamine reaction, basicity of amines, IUPAC names, Hinsberg reagent, reaction with nitrous acid, bromination, sulfonation, and finally diazotization process. So these are the most important concepts where you want to concentrate for scoring the 7 marks. Now we'll see in brief about these concepts. In this video I am going to explain only about these important concepts. Now first we'll see about introduction of amines. These amines are said to be the derivatives of ammonia. We know ammonia. Ammonia is a compound of NH3. It is with the chemical formula NH3. It has one central atom, that is nitrogen, and surrounded by 3 hydrogens. And this is known as ammonia. In ammonia, one or more hydrogens are replaced by alkyl groups. If one hydrogen is replaced by one alkyl group, then it can give primary amine. Okay, in ammonia, if 2 hydrogens are replaced by 2 alkyl group, if you remove 2 hydrogens from here, you will get here NH, and those 2 hydrogens are replaced by alkyl group. Okay, if in this ammonia all the 3 hydrogens are replaced by 3 alkyl groups, you will get tertiary amines. That means these 3 are said to be amines. Those amines can be prepared easily from the ammonia. So we can say these amines are the derivatives of ammonia. In ammonia, one or more hydrogens are replaced by alkyl groups, can give amines as the products. Now we can also take them as types of amines. There are 3 important types of amines, which is known as primary amine, secondary amine, tertiary amine. So they are differing with the only number of alkyl group. If nitrogen of ammonia is attached with only one alkyl group, that is called primary amine. If nitrogen in ammonia is attached with 2 alkyl group, that is said to be secondary amine. On ammonia, if all the 3 hydrogens are replaced by 3 alkyl group, then that is said to be tertiary amines. Now we want to study about their structures. If you observe the structure of amines, in these amines, the central atom is nitrogen. So this is the central atom. Okay, the central atom always participates in sp3 hybridization because around it only single bond is present, so that it can participate in sp3 hybridization. Because of participates in sp3 hybridization, its geometry must be tetrahedral, but here it is with a pyramidal shape because it's not here nitrogen is not with the 4 different atoms. It is maximum of only 3 different atoms, so that it do not show that geometry. Its geometry is pyramidal. This is also important. What is the geometry of amines? That is pyramidal, and the hybridization of nitrogen here is said to be sp3. And the next important concept is nomenclature. Nomenclature is very much important for 1 mark. There is compulsory one question for 1 mark based on the nomenclature of amines. Especially IUPAC nomenclature is most important for 1 mark question. Okay, these are the common names. As you know that common names does not depends on any particular rule. It is mainly depends on the source of extraction, or it maybe depends on the property of a compound. That's it. Common names always depends on that property, whereas IUPAC names always depends upon the set of rules. So from this IUPAC names, compulsory you will get one 1 mark question. Listen carefully. Now here they have given a compound which is known as amine, because in the place of R group here CH3CH2 is replaced. You just go through these common names. Now I am explaining only IUPAC names. Okay. Now first you want to select the parent chain. In IUPAC names we want to write the names of amines as alkanamine. Okay, we want to write their name as alkanamine. Alkane here indicates that number of carbon atoms. To that we want to join the word amine. Okay, this alkane always depends upon the number of carbon atoms. See here, this is the parent chain which consists of only 2 carbon atoms. The nitrogen containing carbon is always given as first number and the next carbon is given as second number. To the first carbon atom here nitrogen or amine group is located and total number of carbon atoms here present are only 2. If 2 are present, in place of ethane we can write about ethane. Okay, whereas suffix E is replaced by amine because of having NH2. We can call it as ethanamine. Okay, we can call it as ethanamine. Like that, we can write other names also. Now see, this is one. Here, the parent chain is this one. Nitrogen or amine linkage containing carbon is given as first number, second number, third. Okay, due to having 3 carbon atoms, we can give the root word as propane and the suffix is amine. We can call it as propanamine. And here, this is the parent chain because continuous carbon chain is taken as the parent chain. First carbon, second carbon, third carbon. At second carbon, amine is attached. So, due to having 3 carbon atoms, we have to call it as propane. And second carbon amine is attached, so we can call it as 2-amine. Propane 2-amine. Next, this one. See here, there is no continuity of the carbon chain. Here, one carbon chain is present. Here, another alkyl group is present. Alkyl group which is containing more, this is an example of secondary amine because on nitrogen 2 alkyl groups are present. On nitrogen 2 alkyl groups are present. So that we have to consider it as a secondary amine. In this case, the nitrogen is with 2 different types of alkyl groups. Then there is a confusion which want to be taken as the parent chain. The carbon chain which is containing maximum number of carbons has to be considered as the parent chain. Okay, more number of carbons has to be considered as the parent chain. This is 1, 2. And this is containing only 1 carbon which is attached to the nitrogen. So we can call it as N-methyl. We can call it as N-methyl because methyl is present on nitrogen. So we want to write it as N-methyl. This N-methyl attached to ethanamine. Okay, ethane plus amine, ethanamine. N-methyl ethanamine. Okay, now this one. Here you may see that nitrogen of amine is attached with 3 alkyl groups. This is one, second one, third one. All the 3 alkyl groups are same. If nitrogen attached with 3 alkyl group, then that is said to be tertiary amine. So among the 3, take one as parent chain. So then this becomes the parent chain. Okay, then only 1 carbon is there. We can call it as methane amine. To this methane amine, 2 methyl groups are attached. Where these 2 methyl groups are attached only on the nitrogen. So we can call it as N, N dimethyl methanamine. Dimethyl methanamine. Why di? Because of having 2 methyl groups on methanamine. So we can call it as N, N dimethyl methanamine. Okay. Now we want to write its name. So this is the parent chain because it has 4 carbon atoms, but it has 2 carbons and it has 2 carbons. Okay, if 4 carbons are there, then that has to be taken as the parent chain. 4 indicates butane amine. To this butane amine, 2 ethyl groups are attached, so we can call it as N, N diethyl butanamine. Okay, like that we can write names for different types of aliphatic amines. IUPAC, remember IUPAC names are very much important for 1 mark. That's why I have explained here. Only IUPAC names. You concentrate on this. Now we'll write names for few other amines. See here, this is the parent chain and it is an example of primary amine. Give numbering from here. 1, 2, 3. Double bond is located at which position? Second position. Then we can call it as propane 2-ene. Okay, propane, prop 2-ene. To this prop 2-ene, amine is attached at first position. Then we can call it as prop 2-ene 1-amine. Prop 2-ene 1-amine. Okay, now the next one. So CH2 taken 6 indicates that this kind of CH2 groups, totally 6 are present on the normal chain. Okay, to the first carbon atom NH2 is attached, to the sixth carbon atom NH2 is attached. So we can call it as, due to having 6 carbon atoms, the root word is hexane. Okay, to this hexane, first and sixth positions are attached with amine, so we can write it as 1,6. Due to having 2 amines, we can write the prefix as di and suffix is amine. Okay, hexane 1,6 diamine. Understand? Now that is about the aliphatic amines. This is aromatic amines. In this aromatic amines, your benzene ring is attached with NH2 group. We can call it as benzenamine, or simply we can also call it by using common name, that is aniline, either benzenamine or aniline. Okay, now this one here, the second carbon atom hydrogen is replaced by methyl group. This has to be given as first number, this has to be second one. At second position methyl is attached, so we have to write its name as 2-methyl benzenamine. 2-methyl benzenamine. Okay, now this name, try to write IUPAC name for this one, homework for you. Okay, now we'll see for this one. Here the nitrogen, on nitrogen how many alkyl groups, how many R groups are present? 2 here and 1 here, totally 3, so we can take it as a tertiary amine. Okay, on nitrogen 2 methyl groups are there, so we can call it as N, N dimethyl. N, N dimethyl. If nitrogen is present on benzene ring, that is called what? Benzenamine. So we can write its name as N, N dimethyl benzenamine. Okay, that's it. That is about the IUPAC nomenclature of aliphatic amines and aromatic amines. Please concentrate on this, because compulsorily you will get 1 mark question from this concept. Now we'll see about the few important preparation methods of amines. There are many important preparation methods, but in that here I am going to explain you only few important, most important preparation methods for the amines. Under that, the first one is reduction of nitro compound. Nitro is nothing but NO2 group. If NO2 group is present either to the alkyl group or aromatic ring, then that is said to be nitro compound. When this nitrobenzene or nitro compound undergo hydrogenation in presence of palladium and ethanol, it can be converted into aniline. Is this aniline one of the amine? Yes, it is aromatic amine. Finally, here we have prepared aniline. This aniline is aromatic primary amine. When nitrobenzene undergo reduction in presence of palladium and ethanol, it can give this aniline. What happened here? The 2 hydrogens present here take 4 hydrogens and eliminates as 2 moles of H2O. In place of 2 oxygens, here 2 hydrogens are replaced and we got here aniline as the product. Or else we can also use another reducing agent, that is tin and HCl. As I already told you that many reducing agents are available in the nature. We can use any one of it. Either we can go through this, or we can also take tin and HCl, or a combination of iron and HCl can also act as reducing agent. When this nitrobenzene is reduced by using reagents, then it can again converts into aniline. This is the one of the method of preparation of amines by using nitro compounds. Now the second most important, many times this question is asked for 2 marks. Listen carefully. Gabriel phthalimide synthesis. So in this case, first we want to take phthalimide. This is phthalimide. Okay, this benzene ring, which is with C double bond ONH and C double bond O, is known as phthalimide. See the suffix. This is imide. When this phthalimide undergo reaction with KOH, potassium hydroxide. First, what will happen here? Hydrogen present on phthalimide reacts with OH of potassium hydroxide, eliminates as H2O. It loses water. Now what is left? Potassium. This potassium is added to nitrogen. We will get potassium salt of phthalimide. This is potassium salt of phthalimide, which again treated with RX, that is alkyl halide. It loses potassium halide. It loses potassium halide, KX. Again, what is left here? R group. This R is added to nitrogen and we will get N-alkyl, to the nitrogen alkyl group is attached. So we can call it as N-alkyl phthalimide is formed. Now this N-alkyl phthalimide, again on reaction with sodium hydroxide in aqueous solution, okay, it finally converts into primary amine. Whenever it is treated with aqueous NaOH, exactly the bond breaks here. Okay, NaOH can be split into NaO minus H plus, NaO minus H plus. Clear? H plus is added to nitrogen, ONA is added to this carbon, OCOONA. In the same manner here also one more mole of NaOH is added. H is added to nitrogen, ONA is added to this carbon. Then what we will get? COONA, COONA. That is what here it is released. And what is left here? RNH2. That is primary amine is formed. This is the best method to prepare these primary amines, which is very much important for 2 marks. When phthalimide reacts with potassium hydroxide, it loses water, can give potassium salt of phthalimide, which again on reaction with the alkyl halide, it converts into N-alkyl phthalimide. On treating with aqueous solution of NaOH, finally it gives primary amines. Okay, and the next most important question for 2 marks. Again, it is very much important for 2 marks. Hofmann bromomide degradation reaction. Degradation, the name itself indicates that here we will get an amine which is containing one less carbon atom than the corresponding reactant. Okay, than the corresponding reactant, you will get a compound here which is having one less carbon, so that we can call it as degradation reaction. Okay, this method is especially meant for the preparation of primary amines. Clear? Now for this reaction we want to take amide. It is also there in the name itself, amide. So amide general formula we know, RC double bond for NH2. When this reacts with bromine and sodium hydroxide, because it is a bromomide reaction, it reacts with bromine and sodium hydroxide solution. First what happens? The CO group is completely removed and NH2 is directly added to R and converts into this compound, which is nothing but primary amine. This primary amine is obtained. Now in this NaOH, 2 sodiums, totally 4 sodiums are there. 2 sodiums reacts with CO3. Here CO is there, by taking 2 oxygens here converts into CO3 and releases Na2CO3. Sodium carbonate is released. We know still 2 more sodiums are there. Here we have used only 2 sodiums. Still 2 more sodiums are there. Those react with bromine can releases NaBr and 2 moles of H2O. And this reaction is called Hofmann bromomide degradation reaction. Here you may see the carbon, presence of this carbon, but here that carbon is not present. That means here we got a compound which is containing an amine less than 1 carbon atom than the reactant. That's why it is said to be degradation reaction. Okay. Now we'll see the most important chemical properties of amines. One of the important chemical property of amine is ammonolysis. See the question, how they will ask. What is ammonolysis? Explain with general reaction. Okay. See, first we'll see the definition of ammonolysis. The process of cleavage of CX bond of haloalkane. This is haloalkane by ammonia is called ammonolysis. The process of cleavage of CX bond of haloalkane by ammonia is called ammonolysis process. Clear? For that reaction, first we want to take primary amine. RNH2 is the general formula of amine, because here they have asked us to write about the general reaction, so that I have taken here general formula of primary amine. When this primary amine reacts with alkyl halide or haloalkane, this bond involves in breakage. Here 2 hydrogens are there. One hydrogen react with X can eliminate HX. And this R group is added to this nitrogen. Already this nitrogen contains 1 R. By adding 1 more R, it converts to R2. R2NH. This is called secondary amine. Now the secondary amine reacts with the RX once again. What is this reaction? Cleavage of CX bond. the CX bond cleaves and H here and X here together eliminates as HX. And this R group again added to nitrogen. Already it is with 2 R groups. By adding one more, it converts to R3N, which is called tertiary amine. This tertiary amine, whenever it is added by one more alkyl group, alkyl halide, again this bond involves in breakage. But to eliminate HX, there is no hydrogen on the nitrogen. Nitrogen mele innondu hydrogen illa. So R is added to nitrogen by taking this lone pair of electrons. R3 becomes R4N. By losing electrons, it will get plus charge. To that plus charge, halogen is also added, converts into R4NX. That is quaternary ammonium salt is obtained. This reaction is called what is ammonolysis, and explain the reaction with general equation. Okay, even this is important for 2 marks. There is a chance to ask this chemical property. Next, basicity. One more important concept from this chapter is basic nature or basicity of amines. From this concept again you will get 1 2-mark question. Okay, first we'll see basic nature. So basic nature, when we can say a compound is basic, if it has the property to attract a proton or to donate a lone pair of electron, then that is said to have basic nature. In amines also, the nitrogen is having the property to donate that lone pair of electron. So it will get that basic nature or basicity. That basic nature increases with increase in the number of alkyl group. Okay, but the order of basic strength in gaseous state is different from aqueous solution. In gaseous state it is different from in aqueous solution. In gaseous state always primary amine is less basic than secondary amine, is less basic than tertiary amine. Okay, that means tertiary amines are more basic than secondary than primary in gaseous state. Whereas in aqueous solution, its order differs. That is due to steric hindrance. This point is very much important. Okay, in aqueous solution, the basic strength of amines is in this order. That is, secondary amines are more basic than primary. Primary is more basic than tertiary. Though the tertiary amines containing more number of alkyl groups, here its basic nature is decreased. Why? Because means in tertiary amine is generally indicated by R, N, R, R. Around this nitrogen, 3 bulky groups are attached. Due to increase in the number of bulky groups, though the nitrogen has lone pair of electrons, the ability to donate this lone pair of electrons decreases. Then automatically its basic strength also decreases. That effect is called steric hindrance. Okay, due to having steric hindrance in aqueous solution, tertiary amines are always having less basic strength than the primary amines, but it is more basic than ammonia. Clear? And it is differing with methylamines as well as ethylamines. Okay, the same order can be seen in the case of methylamine. That is, secondary methylamine is more basic than primary methylamine, than tertiary methylamine, than ammonia. But if it is in ethylamine case, tertiary ethylamine is more basic than secondary than primary. You have to remember even this. In the ethylamine case, this is the reason. So this is the order of basic nature. Tertiary ethylamine is more basic than secondary than primary. But in methylamines case, this is applicable. Secondary methylamine is more basic than primary, than tertiary, than ammonia. Now we will compare the basic nature of aniline with ammonia. If you observe both aniline, this is aniline and this is ammonia. Aniline is less basic than ammonia, because in aniline, though the lone pair of electrons present on nitrogen, that is not free. It involved in resonance. Okay, that lone pair of electrons involved in resonance with the lone pair of pi bonded electrons present in the ring. So that these are not free in state. If these electrons are not in free state, then it will not attract the proton. If the property to attract the proton decreases, basic nature also decreases. That is why the reason The aniline is having less basic strength than the ammonia. Aniline is less basic than ammonia because the lone pair of electrons in aniline is involved in resonance. Okay, here I am giving a question for you. You want to arrange. So if you clear, you just solve this question, send your answer to me. See, basic nature, it is different. Basic nature always increases with when number of alkyl groups increases, because each alkyl group is acting as plus I effect group. That means which can donate number of electron pairs. If they donate electron pairs to the nitrogen, electron density on nitrogen increases, the property to attract the proton increases, basic nature also increases. Are you clear? Now, the basic strength in gaseous state is different from basic strength of amine in aqueous solution is different. Within this aqueous solution, it is different for methylamine and ethylamine. Ethylamine is in the same order of gaseous state, but methylamine, it follows this order. And when you compare basic strength of aniline and ammonia, ammonia is more basic because the lone pair of electrons on nitrogen is involved in resonance. And based on this concept, you try to solve this question. This is homework for you. There is compulsory question for 2 marks from the basic strength. There is compulsory question. There is no doubt of it. Okay, try to solve this. And we'll see a few more questions related to this basic strength. Here are the few questions. Here you can see. Aliphatic amines are stronger bases than ammonia. Give reason. Aliphatic amines are stronger bases than ammonia. Give reason. This is due to plus I effect of alkyl groups of amine. Electron density on nitrogen atom increases. So aliphatic amine is stronger base than the ammonia. See here I have taken aliphatic amine and ammonia. So in ammonia, nitrogen is attached with only 3 hydrogens. But in aliphatic amine, nitrogen is attached with alkyl group. These alkyl group, how they are acting? They are acting as plus I effect group. That plus I effect groups are having the property to donate electrons. When they donate electrons to the nitrogen, electron density on nitrogen increases. Automatically, it easily attracts the proton. Clear? So its basic nature increases. That's why aliphatic amines are more basic than the ammonia. Next most important question for 1 mark is ammonia is stronger base than aromatic amine. Give reason. Aromatic amine is nothing but aniline. Okay, this is aniline. Aromatic amine, this is ammonia. Due to plus M effect of aryl group. This is aryl group. This aryl group is plus M effect group. Okay, which decreases the electron density on nitrogen, because by taking this lone pair of electrons, it involves in delocalization, so that the electron density on nitrogen decreases. Whenever this electron density decreases, the property to attract the proton also decreases. So ammonia is more basic than the aromatic amines. These two are also important questions for 1 mark. Next important chemical property for 2 marks. This is also another important question for 2 marks. Carbylamine reaction. In this carbylamine reaction, primary amine, aliphatic primary amine reacts with chloroform and potassium hydroxide, and it gives a isocyanide or carbylamine. Another name for carbylamine is isocyanide. Foul smelling isocyanide or carbylamine is formed, and the reaction is called carbylamine reaction. Remember, this test is used to test for primary amines. How can you find the primary amines by this test? Means because of that foul smelling. Okay, we cannot see this carbylamine or isocyanide which is formed, but by observing that foul smell, we can easily confirm the given amine is primary. Okay, secondary and tertiary amines do not show this test. Okay, only primary amines react with chloroform and this potassium hydroxide. It converts into this carbylamine. What happened here? These 2 hydrogens are removed and this carbon is added here, converts into RNC. RNC is the formula of this carbylamine, and 3 potassiums reacts with Cl, eliminates as 3KCl. Remaining oxygen and hydrogens together releases H2O. Finally, we got here carbylamine as the final product. or isocyanates. Now the next chemical reaction is reaction with nitrous acid. Nitrous acid formula is HNO2. Nitric acid is HNO3. Aliphatic primary amines are having the property to react with this nitrous acid as well as aromatic primary amines react. When aliphatic primary amines react with nitrous acid in NaNO2 and HCl, first it gives aliphatic diazonium salts which are highly unstable and undergo hydrolysis and gives alcohols. Remember, this is in the case of aliphatic primary amines. When aliphatic primary amines, remember this is only in aliphatic primary amines. Final product is alcohol. Aliphatic primary amines are generally indicated by RNH2. RNH2 when react with nitrous acid. Nitrous acid HNO2 we can also write in this form ONOH. NaNO2 and HCl. First what happens? This H2 and O reacts, eliminates as H2O. Okay. Then this OH and H together eliminates as H2O. 2 moles of H2O is released. Now what is left? This OH and Na eliminates as NaOH. This H and oxygen eliminates as H2O, and nitrogen is added to this nitrogen, converts to N2. To that N2, Cl is added, converts into RN2Cl, RN2Cl. This is called aliphatic diazonium salt, which is highly unstable, undergo hydrolysis and converts finally into alcohol. This is aliphatic primary amine. If you take aromatic primary amine, this aromatic primary amine also react with nitrous acids, converts into aromatic diazonium salts. It stops with the formation of aromatic diazonium salt, which is stable when compared to this one. Okay. So here I am taking aromatic primary amine, that is C6H5NH2, which is known as aniline, when it reacts with sodium nitrate and 2HCl. Okay, one oxygen here react with H2, removes H2O, and 2 hydrogens here take here one more oxygen, eliminates as H2O. And what is left here? This nitrogen and 2Cl. In that 1 Cl react with sodium, releases NaCl, 2H2O, and that 1 Cl and 1 nitrogen reacts with the nitrogen, converts into C6H5N2, C6H5N2Cl. This is called benzene diazonium salt. Benzene diazonium salt. Okay, the same N2Cl is present on aliphatic ring, that is called aliphatic chain, that is called aliphatic diazonium salt. If it is present on benzene, we can call it as benzene diazonium salt. And this total process is known as diazotization reaction. Okay, here you may cover 2 reactions, 2 questions. One is explain the reaction of aromatic or aliphatic amines with nitrous acid, or explain diazotization. Diazotization is a process of preparation of benzene diazonium salt from aniline. When aniline react with sodium nitrate and HCl at 273 to 278 kelvins, it can give benzene diazonium salt, and this is called diazotization process. And next, another important chemical reaction is reaction with aryl sulfonyl chloride. This aryl sulfonyl chloride is known as Hinsberg reagent. This is called Hinsberg reagent. Aryl sulfonyl chloride is known as Hinsberg reagent, and the reaction is called Hinsberg's reaction. So very important for 1 mark. What is the reagent? What is Hinsberg reagent? C6H5SO2Cl, or we can also call it as aryl sulfonyl chloride. This is called Hinsberg reagent. By using this Hinsberg reagent, we can distinguish primary, secondary and tertiary amines. To distinguish primary, secondary and tertiary amines, we can use this reaction. That is called Hinsberg reaction. What is Hinsberg reagent? C6H5SO2Cl. That is nothing but aryl sulfonyl chloride or benzene sulfonyl chloride. When that aryl sulfonyl chloride, this is C6H5SO2Cl. Okay, so for our convenience I have written in this manner. This Hinsberg reagent, when react with primary amine CH3NH2, when it reacts with primary amines, first what happens? Cl reacts with this hydrogen, releases HCl. Then the sulfur is directly now attached with nitrogen, converts to C6H5SO2NHCH3, and this is called N-methyl, or nitrogen methyl group is attached, N-methyl benzene sulfonamide. This is called sulfonamide, N-methyl benzene sulfonamide. So this is soluble in alkali. Okay, when primary amines react with Hinsberg reagent, it gives a compound which is soluble in alkali. Now we'll see the same reaction of Hinsberg reagent with secondary amine. This is Hinsberg reagent. When it reacts with secondary amine, hydrogen react with chlorine and releases HCl. Now directly NCH3 taken twice reacts with sulfur, can get this compound. On nitrogen, how many alkyl groups are present? 2. Then we can call it as N, N dimethyl benzene sulfonamide is formed as the final product. Clear? This is insoluble in alkali because of the absence of nitrogen, hydrogen and nitrogen. And nitrogen, there is no hydrogen, so it is insoluble in alkali. That means secondary amines react with Hinsberg reagent, can give a compound which is insoluble in alkali. By this we can confirm the given amine is secondary. If it is soluble in alkali, then that confirms that primary amine is given. Whereas this tertiary amines do not undergo reaction with benzene sulfonyl chloride or Hinsberg reagent. There is no reaction because no hydrogen is left on the nitrogen of tertiary amine, so that it do not undergo reaction with Hinsberg reagent. This is another most important reaction for 2 marks, or there is a chance to ask for 1 mark. What is Hinsberg reagent? Benzene sulfonyl chloride or aryl sulfonyl chloride is called Hinsberg reagent. That means within the same concept you will get 3 marks. 1 mark question, what is Hinsberg reagent and why we can use this Hinsberg reagent, that is to distinguish primary, secondary and tertiary amines. Now the next reaction, chemical property is bromination. When bromination is nothing but substitution of bromine on benzene ring. Especially this bromination takes place only on the aromatic amines. When aromatic amine undergo bromination in water, okay, bromination in water, it gives tri-substituted product. Okay, this is strongest brominating agent, so we will get here tri-substituted product. This is first position, and amine containing position is first, second, third, fourth, fifth, sixth. At second, fourth and sixth positions bromines are present, so we can call it as 2,4,6 tribromoaniline is formed. If the same bromination takes place in presence of pyridine or acetic acid, either in presence of pyridine or acetic acid, it can give a major product as 4-bromoaniline. Mono substituted product is obtained because it's a mild brominating agent, so we will expect only mono substituted product. These two are very much important for 1 mark. Here are few more important questions, how they will ask these concepts as question wise. See, this is a question related to basic nature. So arrange the following in increasing order of their basic strength. Here they have given 3. You have to arrange them in the basic strength. So you just go through that basic strength concept and arrange them according to their basic strength. This is homework for you. Compulsory, you have to do this and send your answers to me. And next question, identify the product X, Y and Z in the given following conversion. Okay, here they have given a question. When aniline undergo acylation, it gives X. Which on bromination in acetic acid gives Y. Which this Y undergo hydrolysis can give Z. We want to complete this reaction. Find X, Y and Z. Acylation. So first you want to know what is meant by acylation. In many times we have seen this acylation. Acylation is nothing but addition or substitution of acyl group. Acyl group is nothing but CH3COCl. When this acyl group undergo reaction, what happens? So it releases HCl. Hydrogen from aniline reacts with Cl, releases HCl. Now on nitrogen, one bond is less. COCH3 is added to nitrogen. Then we will get here, in place of this X, we will get C6H5, NH2 becomes NH and COCH3 is added. We will get this compound. This is called acetanilide. This is acetanilide is formed as X. Now acetanilide undergo bromination in presence of acetic acid. When it undergo bromination in presence of acetic acid, bromination in presence of acetic acid are pyridine. Just now I have told you it is a mild brominating agent. We will get only one major product, that the hydrogen present at this position, para position, react with bromine, one bromine, releases HBr. Now at the place of hydrogen another bromine is substituted. Then we will get NHCOCH3 at para position bromine. Now this is first position, second position, third position, fourth. Fourth position bromine is attached. 4-bromoacetanilide. Byproduct is 4-bromoacetanilide or para-bromoacetanilide. When it undergo hydrolysis, we are adding water. Exactly here the bond involves in breakage. H3O plus is acid hydrolysis, H plus H2O. In water, H plus is added to nitrogen, OH is added to CH3CO. Converts into CH3COOH. It releases CH3COOH. What is left? Here we are getting Z product. Br is present as it is. Here we are getting NH2 back. This is called 4-bromoaniline. Okay, Z product is 4-bromoaniline. We can also call it as para-bromoaniline. Okay, so like there is a chance to ask a question like this also. You have to prepare thoroughly. You want to know what is acetylation, what is the product when bromine react with acetic acid, or what is hydrolysis product. That's it. Then you will find the answers. Now next question. Give the equation for the conversion of aniline to 4-bromoaniline. Is this aniline? Yes, exactly, aniline. Finally it converts into what? 4-bromoaniline. So what is the question here? Give equations for the conversion of aniline to 4-bromoaniline. The same question there is a chance to ask in this way also. Now how is aniline is prepared from nitrobenzene? Write the answer for this, because I have explained this in this video. Okay, now the next question. How do you convert methyl cyanide into ethylamine by reduction by catalytic hydrogenation method? Here they have given a clue: reduction and catalytic hydrogenation. Okay, reduction is nothing but addition of hydrogen. Catalytic hydrogen is also nothing but addition of hydrogen in presence of a catalyst like nickel, palladium or platinum. Now here methyl cyanide, this is methyl cyanide. We can also call it as methane nitrile. Methyl cyanide is also known as methane nitrile. 4 hydrogens are required for this complete reduction. These 2 pi bonds involves in breakage. When 2 pi bonds involves in breakage, here 2 hydrogens are added. Converts into CH3, CH2, NH2. Okay, here 2 carbons are present on the parent chain. We can call it as ethanamine, or we can also call it as ethylamine. Ethylamine is a common name. Ethanamine is a IUPAC name. And next question. When aniline is treated with HNO2 at 273 to 278 kelvins, benzene diazonium salt is formed. Write the equation and name the reaction. This is also I have explained within this video. You just try to find out the equation and send answer to me along with name of reaction. Next, here are a few more questions for you. Complete the following equations. Okay, even this we have seen just now. Reduction, catalytic reduction. What is the product? RNH2 CHCl3 and KOH. What is this reaction and what will be the product? When bromination takes place in presence of water, what will be the product? Whether it can give tri substituted product or mono substituted product, you have to find. And next, few more questions I have given. Write IUPAC names of these compounds. Okay, this is about the chapter amines. This is enough to study or prepare only these questions and important topics, not only for this term exam, even it is enough for the final exam. Okay, these are the concepts which are frequently asking from this amines. From this amines, totally you will get 7 marks for this academic year. One 2-mark question and one 5-mark question. There is no direct 5-mark question. 2 plus 2 plus 1. Okay, so you just concentrate on these important topics, and this is the smallest chapter which is present in organic chemistry and more scoring subject, more scoring topic. And try to solve all these questions, send answers to me without fail.